So thank you, Sarah. So as she mentioned, I'm Geneviève Vézina. I work at Statistics Canada as a methodologist, and I was working on the last cycle of time use in the General Social Survey. So today I will present how to use data on time use in the GSS. So we will start with a little description of the survey just to put some context to the presentation. Then we'll go to the variables on the episode file because it is the most difficult file to use, so we'll put a little bit more time on it. We'll see the link between the main file and the episode file. Also, in time use, there are two different weights available, so we'll see which weight we should use for the analysis, when to use the person weight and when to use the episode weight. Then we'll see the measures of time use, so which estimates we can get from the main file and which one we can get from the episode file. Then we'll go to the example. So we'll go into the program, in the SAS program, the startup program, to see how we can use the different file. Just to let you know, I'm a SAS user. I'm not a Stata user, but I do have the programs for both. And then we will conclude. So the particularity of this cycle is the diary. So it's a good way to get accurate information about people's time use. So we were asking respondents to tell us all the activities of at least 10 minutes they did during a specific day of the week from 4 a.m. in the morning for 24 hours. So we had questions about the nature of the main activity, the duration, the location, with who the respondent was, the simultaneous activities. So at the end, we get two different analytical files. So we have the main file with one record by respondent, and we have the episode file where we have one record by activities reported by the respondent. So this is a whole screenshot of how we were asking information in the diary. So we're asking what was the activity, at what time it started and ended, the simultaneous activities, with who the respondent was and where he was. So this survey tracks patterns of time use. So it's to better understand how Canadians use and manage their time and what contributes to their well-being and stress levels. So we can answer a question like, are we working too many hours? Do we have enough time to play sports, to volunteer? Do we spend quality time with our family, children, friends? So this is why we have this survey. So the variables on the episode file. So this is not all the variables, so we'll see the main one, the one we'll be using today. So we have the TUI01, which is the activity code of the episode. The TUI06A2J indicates who the respondent was with during the activity. We could be with up to 10 people for each activity. The TUI03A and B are the first and second simultaneous activities, so we could have max of 2. The TUI10 is the level of subjective well-being. So this was asked twice during the interview. So respondent has to say on a scale from -3 to +3 how pleasant was the activity. And of course, we have the duration, location, the reference date of the diary, the episode weight. I won't spend time right now on it. We'll see that in section 4. And we have the POMF ID, which is the record identification number. So it is related to the respondent and not to the episode. The POMF ID is when you're using the micro data files, the POMF. On the analytical file, it's the rec ID, but it's all the other variables are the same. So the link between the main file and the episode file. So on the main file, you have aggregated information. So you have the total time spent on each activity, the total time spent at various locations, and the total time spent with various persons. So you don't have any detail at the individual activity episode. On the episode file, you have all the detailed information on each activity episode. So you have the start time, end time, the duration, location, the simultaneous activity, who the respondents was with. So the unit record for this file is the episode. So if a respondent reported 26 activities during his day, on the episode file, we would have 26 lines for this respondent. So one line by activity. Several variables from the main file were derived from the episode file. So all the duration, the DUR, are linked to the TUI01 variables on the episode file. So the total time spent on each activity. The DURL are linked to the location variables, and the DURS are linked to the TUI06A2J, so it's the social contact. So we'll see a little example to better understand how we could derive this. So this is an extracted from the episode file for one respondent who did 18 activities during his day. So we have the PONF ID for this respondent. We have the activity code for each episode, the duration, the location, and who the respondent was with during each activity. So if we want to derive the activity's duration, what we would need to do, we would need to sort the file by the TY01 variable for each respondent, sum up the duration, and those values would be the values we would find in the DUR variables on the main file. So if we take our example, for our respondent, we sort by the TY01. So we have 3 episodes of the activity 1. We sum up the duration. We get a 510 minutes for the activity 1. So on the main file, for the variable DUR01, we should have 510. For the activity 2, we have only one episode of 30 minutes. So the DUR02 should be equal to 30, and so on. So on the main file, we have the following variables for the respondent. So as we mentioned, for the DUR01, we have a 510 minutes. For the DUR02, we have the 3 minutes, and so on. So all the other DUR variables are equal to 0 because the respondent didn't do the activity. One thing to know, the sum of all the DUR has to equal 1,440 minutes, so 24 hours. And there is also variables to indicate the frequency of episodes for each activity. So if you remember, for our respondent, he did 3 episodes of activity 1, so the EP1 would be equal to 3. We had only one episode of activity 2 and 5, so the EP02 and EP05 are equal to 1. We can do the same thing with the location variable, but this time we have to sort by the location variable by respondent, sum up the duration, and the sum are the values for the DURL variable. So again, if we take our example for our respondent, so we sort by the location variable. We have 11 episodes at home or on property. So this is the code 300 of the variable location. So when we do the sum of the duration, we get 1,180 minutes. So we would expect on the main file to have the variable DURL300 equals to 1,180 minutes. So if we look at what we have on the main file, this is what we were supposed to get. All the other DURL variables are equals to 0 because the respondent didn't spend time at those locations. And again, the sum of all the DURL variables has to be equal to 24 hours. Finally, we can do the same for a social contact, but this time we have to do the sum for each TUI06 variables, some from A to J, and all the values would be the value for the DURS variables. So again, if we take our example, our respondent had 3 different social contact during his day. So the TUI06A is alone. It's the code 200. So when we sum all the duration of the episode where the respondent was alone, the sum should be the value to the DURS200 on the main file. So this is what we have on the main file. All the other DURS are equal to 0. One thing, the sum of the DURS won't necessarily sum to 24 hours because we can be with more than one person during an activity. So it can be higher than 24 hours, but it could not be lower. And we can create a combined file using the pump ID. So why would we want that? Well, sometimes we need all the information at the episode level, but we also need the characteristic of the respondent to do the analysis. So using the combined file allows you to have everything in the same file. However, when using the combined file, you have to be really careful how you're using it. So why? On the episode file, you have one line for each episode done reported by the respondent. On the main file, you have one line for each respondent. So when you merge both files, you have all the lines from the main file will be repeated for each episode. So you really need to be careful to not double count some of the variables in your analysis. In section 6, we will see some examples how to use this file. Now the weights. As I mentioned earlier, we have 2 different weights in time use. We have the episode weight and the person weight. So the person weight is the basic weighting factor for analysis at the person level to calculate estimate of the number of persons having one or several given characteristics. So if we do the sum of the person weight, we get the estimate of the number of persons aged 15 and over in the population at the time of the survey, so in 2019. The episode weight is the basic weighting factor for the analysis at the episode level, so to calculate estimates on the number of times an activity is done by Canadian population. So the sum of the episode weight gives us an estimated total number of activities performed in a day by the population 15 years of age or older at the time of the survey. So basically, the episode weight is the person weight applied to all the episode. So we'll see a little example to understand what I mean by that. So which weight should we use in the analysis? So we have to ask ourselves, what is the unit of interest for our estimate? Do we want to know an estimate at the person level or at the episode level? And don't forget to always use the weights during the analysis. So on the left, you have an example of the episode file. So we'll imagine that it's all the same activity. And on the right, you have a main file. So as you can see, we have the total duration for each respondent. So here we had 3 episodes. We sum up the 3 duration, we get the 60 here. And as I mentioned, the person weight is applied to each episode, and it is now called an EP weight, episode weight. So if we want to do the average at the episode level, so we have all the episodes that contribute separately. So we want the estimated time spent on the activity per day divided by the estimated number of activities performed in a day. So we have to do all the duration of the episode multiplied by the episode weight, and we divide it by the sum of the episode weight, we get a 16.4. If we do the average at the person level, so we have the total duration by person multiplied by the person weight divided by the sum of the person weight, so it's the estimated total time spent on the activity per day divided by the total number of persons in a given population, so we get a 27.3. So what does it mean? An episode has an average duration of 16.4 minutes, but a person does the activity for 27.3 minutes on average. So when the respondent reported this activity, it was with an average duration of 16.4, but the person does it 27.3 minutes on average every day. So now, which file should we use, main file or the episode file? So it depends on what do we want to analyze. So do we want to analyze the episode or the person? And also, do we want to look at one characteristic from the diary, or do we want to analyze two characteristics or more from the diary? So for example, using the main file, we could estimate the total time spent sleeping, but using the episode file, we could estimate the total time spent sleeping not at home. So as you can see, with the episode file, you can combine information. So you can look at an activity and where you were or with who you were. So now, one thing I forgot, if you're interested by the subjective well-being, so the TY10 variables, this is linked to the episode and not to the respondent, so you have to use the episode file if you want to analyze that. So now the measures of time use. There are three measures frequently used to analyze time use data. So we have the participation rate, the average time spent on activities by participant, and the average time spent on activity by the total population. So the average time spent on activity in the total population will always be lower than the average time by participant, except if the participation rate is 100%. And why is it like that? Well, when you use the total population, you have people who didn't do the activity. So of course, you're adding zeros in your calculation of the mean. So the participation rate is the percentage of the population having reported the activity. So it is the estimated number of persons doing the activity per day, so the numerator, divided by the estimated total number of persons in a given population. We will see some example a little bit later, but we'll start with all the definitions. The average time spent on activities by participant, how would we calculate that? Well, it is the estimated total time spent per day on an activity, so numerator, divided by the estimated total number of persons who reported the activity. So the difference between this average and the next one, which is for the total population, is the denominator, where we have the estimated total number of persons in a given population. So some little notes before going to the examples. So the participation rate and the average time can be calculated for any subgroup of the population. So it means you can calculate your participation rate for men only, women only, for age group, for a specific day of the week. The average time spent on activity is usually calculated based on the 24-hour period over a 7-day week, but you could choose to do the analysis for only one day, so using the D-day variable. The average time for all activities for a total population can be added to obtain average time for a grouping of activities. So what it means, so if you know that you have an average duration of 8 hours sleeping and an average duration of 8 hours working, the group of activities, sleeping, working, is a 16 hour, an average duration of 16 hours. But this is only true if you're using the total participation and not uh, only the participant. And finally, as I said, we can combine both files using the POM ID. So now we'll go into some little examples before going to the SAS program and the startup program. So the participation rate. So it is the percentage of the total population that reported the activity. So we will have a look at the following example. We want to know the participation rate of employed men who did paid work compared to men in general who did paid work. So this is the variables we will be using. We'll note about the PDWK variable. So on the main file, you already have some total duration of multiple activities. So all the activities related to employed work were summed to give this variable. So instead of using 4 different DUR variables, we'll use the sum. And the act 7 days is to know the main activity in the past 7 days because we want to look at employed men. So a little reminder of our equation to calculate the participation rate. So how would we do that? For the first participation rate, so men who did paid work, the numerator would be the sum of the weight for respondents that are men and did some paid work, and the denominator would be the sum of the weights for all respondents that are men. The second participation rate, the difference is with one employed man. So for the numerator, we would do the sum of the weight for respondents that are employed men and did some paid work, and the denominator, instead of only having men, we would have employed men, the sum of the weights for employed men. So this is what we get. So on an average day, 46% of males have spent time at employed work compared to 68% of employed males who have spent time at employed work. It could seem low, but remember that on GSS, on time use, we only ask details for 1 day. So this is for an average day. So maybe you could have selected only the weekday if you want to know for people who, well, most of people work during the week. So you could have decided to choose with the D-day variable, select only the weekday. So you decide what you want to analyze. So I have the SAS code for a first participation rate and the Stata code for a second participation rate. We won't go into the programs now because we'll see that in the next section, but it is there if you need it. Now with the episode weight. So we have 2 different statistics we can get. So we can get estimate at the person level or at the episode level. So, and as I mentioned, we have 2 different weights. So if you're, for the episode weight, it is a way to use when using the episode file to make estimate based on the episode. And if you're, when the episode file is used to derive a respondent characteristic, the person weight should be used to derive characteristics. So we will have examples for both. So person-based statistic and estimate. So when weighted estimates for the average amount of time spent daily at an activity at a given location. So we are looking at 2 different characteristics for the episode. So we need to use the episode file. The estimate is person-based, so we'll have to use the person weight, but we have to derive a total duration for each person. So the example we'll be looking at is the weighted estimates for the average amount of time spent daily on paid work at main job. So again, I put the variables we will be using. So how would we calculate that? So it is the estimated total time spent on activity per day divided by the total number of persons in a given population. So we first need to derive a variable we'll call durand, which is the total duration for each respondent. So we need to derive this using, by creating a counter. So for each episode that meets our characteristic, we will sum up the duration. And at the end, so you will have this counter. At the end, you will keep only the last line with the total time spent. So to better understand, we'll see a little example of that. So you have an episode file. So we see that we have many episodes for the same respondent. In red, you have the episode that we are interested in. So paid work at home. We create the counter durand. So we sum up the duration when the episode meets the characteristic we want to look at. And at the end, for each respondent, we have the total. So we keep the last line for each respondent with the total duration. We can remove variables related to episode because it doesn't make sense anymore because you're keeping the last row. So you should be keeping only what you're interested in. So you keep the total duration, and your episode weight is now actually the person weight, because remember I told you that the episode weight is the person weight that we apply to each episode. So keeping the last line, we keep only one episode weight, so it corresponds to the person weight. So now our equation is the person weight multiplied by the total duration divided by the sum of the person weight. We get a 19 minutes. So on an average day, Canadians spend 19 minutes working at their main job while they are at home. So this seems really low, but maybe it is because we don't have a lot of Canadians working from home. So we should have looked at the participation rate maybe before, and this is the average time in the population. So maybe we should have looked at the average time by participant. So just to let you know, we have the SAS code and the Stata code for the previous example. We won't go into details right now because we will see some example in the next section. So as I said, we should have looked at the participation rate. So we can derive participation rates from both from the episode file and the main file. So in the episode file, it is the estimated total number of persons doing the activity per day divided by the total number of persons in a given population. So doing this, we get that on an average day, 5.8% of Canadians do some work at their main job while they are at home. So now the average time spent by participants. So the only difference now is the denominator, where we keep only participants. And we get that on an average day when they do some work at home, Canadians spend 326 minutes working at their main job while they are at home. So it makes more sense. So always ask yourself if you should be doing average time in the population or per participant. Now, the episode-based statistic and estimate. So weighted estimate for the average duration of a single episode of a certain activity. So we are looking for the average time of one episode of the activity and not the average time Canadians spend on the activity. So we want each episode to contribute separately. So the example we'll be looking at is the weighted estimate for the average duration of a single episode of watching television. So again, I put the variables we will need for this analysis. So our equation is the estimated total time spent on the activity per day divided by the estimated the number of activity performed in a day. So we get that on an average day, when an episode of watching television is reported, 115 minutes on average is spent on it. It doesn't mean that Canadians spend 115 minutes doing the activity per day. It's really when they reported an activity watching television, it has an average duration of 115 minutes. So again, we have the SAS code and the Stata code for this example. So now we'll go into the SAS programs and the Stata programs to look at 4 different examples. So the first one will be the average time that Canadians spend per day eating. So for this one, we could use the main file or the episode file. We will use the main file for this first quick example. The second one, number of times on average that Canadians ate and how much time it took them on average each time. So again, we could use the main file or the episode file. For this one, we'll use the episode file to have a small example how to derive a counter. So it will be a good introduction to the counters, how to derive them. The third example is the proportion of Canadians who ate all their meals alone or without their spouse partner. So for this one, we need the information at the episode level because we want to know with who the respondent was when he was eating. But we also need information from the respondent, so we need to know, does the respondent has a spouse or a partner? So we will be using the combined file for this one. And finally, I didn't talk much about simultaneous activity, but we will use them for this last example. So proportion of Canadians who watch TV while eating. So we need the main activity and simultaneous activity. So we will use the episode file for this example. So we will be looking at SAS programs and Stata programs. So the first examples we are looking at is the average time that Canadians spend per day eating. So one thing, you have to look at what do you want to analyze. So it is eating. We have 2 different variables of duration of eating. So the DUR06 is eat and drink, and the DUR12 is break or dinner. So we will create a new variables duration eating, which is the sum of the 2 variables here we have on the main file. And after that, we can do the mean of our new variable only for participants. So we only want to include people who ate during their day. And we use the person weight. You can use the bootstrap weights. So I put the little code here with the proc survey means if you want to get all the statistics of your estimates. We have the same thing in Stata. So just one thing, the link here will have to be changed. So to put the link where your data are. So for this first example with Stata, you do the same using the main file. You derive your variable time spent at eating, which is the sum of the DUR06 and DUR12. And you can do the mean of these new variables only for your participant. You have the code if you want to use the episode file and the combined file. We will actually have a look at the combined file just to see how we would use it. So you have the same in SAS. So using the combined file, remember I said that all the variables from the main file will be repeated the number of time you have episode for your respondent. So if you want to use the variable from the main file, you need to keep the last row to not have duplicates for those variables. So how do we keep the last row? We can use the last point pump ID So it is by respondent, and you keep the last row. You derive your new variable duration eating, and after that, you do your proc means the same way we did it with the main file. You can use the bootstrap weight, so using the proc survey mean, and you have the exact same thing in Stata, so you keep the last row for each respondent, you create your new variable, and you do your mean for your participant. The second example is the number of times on average that Canadians ate and how much time it took them on average each time. So this one could be done with using the main file, but we will be using the episode file to see how to derive a counter. So again, so we need information at the person level. So we'll derive for each respondent the number of time the respondent ate and the duration eating. So every time we meet an activity of eating, we add that to our counter. So here's the duration, and here is every time we eat, we add 1 to our counter. At the end, we keep the last row with the total time spent or the total number of time the respondent ate, and we keep only variables that we need. In this example, we didn't want to know the average time of an episode eating, but we want to know the average time a respondent ate each time he was eating. So we need to create a mean. So we actually want the mean of the mean. So we have to derive this new average time by respondent, and we will do the mean of those average time. So to do that, again, it's a proc mean of your number of time you ate and the duration, your mean duration for each respondent. You keep only participant to the activity, so person who ate during their day, with the weight. So remember, when you keep the last row, your episode weight is actually the person weight. You have the exact same thing in Stata. So you have how to derive your counter for the duration of eating and the counter for how many times you ate. You derive your mean duration for each respondent, and you can calculate the average, the weighted average for the duration and the number of time. So doing that, you would get that on average, Canadian ate twice a day, and each meal took around 44 minutes. The third example is the proportion of Canadians who ate all their meals alone or without their spouse. So as I said, we need information from both files. So I have a lot of code because everything that could be done with each file is there. So you have all the example. So we'll look at how we would use the combined file. So we want to know how many meals were taken. No, the proportion of Canadians who ate all their meals alone or without their spouse. So we will derive a new counters for who the respondent was when eating. So I created more counters than what we need, so we will have everything to analyze the eating episode. So first we have the same two counters, so duration eating and number of time the respondent ate. Here we want to know the duration of eating alone. So every time we were eating, so we had the activity 6 or 12, and we were alone, so the TY of 6A equals 1. We sum up the duration. And if you were not alone, well, the TY of 6A doesn't equal 1. We could create counters to know how many times we take meals alone, with spouse or partner, with children, younger than 15 years old, or all children's in the household, with parents, friends, family. So I have all the counters here. At the end, we have to keep the last row again with the total of the counter for each respondent. And now we derive the information we want. So we want to know who took all their meals alone. So if the number of meals you took alone is equal to the number of times you ate during your day, you took all your meals alone. Also, if you want to look at people who ate with their kids, well, you have to know if the respondents have kids in the household. So using the variables from the main file, you can derive information if the respondent has kids or not. Same thing for spouse or partner. So if you want to know the proportion of Canadians who hate without their spouse, well, you need to know if you had a spouse. So this is how you would do it. And I put how you could derive regions if you want to do the analysis by region. At the end, you keep only variables you need. So to know the proportion of Canadians who ate all their meals alone, you would do a weighted frequency of this variable alone that you derive. You can use the bootstrap weights again using the proc survey FREC. And for proportion of Canadians who took all their meals without their spouse, you could do the weighted frequency of EB, which is the number of time you ate with your spouse. So you look at the frequency of 0. And again, you can use the bootstrap weight. So you would get that 30% of Canadians ate all their meals alone, and 30% had not eaten any meals with their partner during an average day. Finally, I'll go in this data before going to the next one. So for example 3, you have how you would derive it with the episode file, and you have with the combined file. So you have how to derive a counter with the combined file, well, using stata. So you have all the same counters that we just saw in SAS. And at the end, you keep the last row. You create your indicator variables to know, well, who took all their meal alone? Do you have kids? Do you have a partner? The regions. And you can do your proportion for who took their meals alone, and proportion of Canadians who took all their meals without their spouse or partner. And you have the code also for the distribution of Canadians who ate with their children if you want to know. Last examples, the proportion of Canadians who watch TV while eating. So for this one, we have to use the simultaneous activities, but you have to decide what do you want to include. So we want to look at people who ate while watching television, but do we want to include only activities, well, episode where the main activity is eating and the simultaneous activities is watching TV, or you also want to include episode where your main activity is watching television and your simultaneous activity is eating. So in my example, I kept everything. So eating as a main activity or as a simultaneous activity. So I will be using the combined file. So again, we need to derive information at the person level. So we need to create a counter of how many times people ate while watching television. So we do it the same way. We have a counter of how many times we ate, because this time it is a little bit different since we are considering simultaneous activities. So every time you eat could be a main activity, or the first simultaneous activity, or the second simultaneous activity. For a counter of eating while watching television, so the first situation is you're eating as a main activity and watching television as a first simultaneous activities or second simultaneous activities. And you have to consider watching television as a main activity and eating as a first simultaneous activity, or eating as a second simultaneous activities. At the end, you keep the last row to have the total of each counter. And we derive the indicator to see if the respondents have watched television at least one time while eating. So if our counter is higher than 0, then we have watched television while eating. And we can do our weighted frequency of how many people watch television while eating. We only keep people who ate during their day. We can use the bootstrap weights again. So we get that 35% of Canadians watch television while eating. And we have the exact same thing with the stata. So we have here how to derive the number of time you were eating, the number of time you were watching television while eating. So eating as a main activity and watching television as a simultaneous activities. And here you have watching television as a main activity and eating as a simultaneous activity. You keep the last row. You create your indicator to know if the respondent have watched television at least one time while eating, and you can do your weighted frequency. So before using the time use data file, you have to ask yourself what you're looking for. So always know what you want to estimate. Do you want person level estimates or episode level estimates? Determine your unit of interest, find your population of interest. So do you want to keep all the population? Do you want to keep only participants to the activity? And based on that, determine which file you should use. So if you're looking at only one characteristic of the diary, you can use both files. But if you want to look at more than one characteristic, so the main activity combined with the location or combined with who you were, or maybe the three characteristics at the same time, you need to use the episode file. Thank you. Any questions?